Okay. This similarity, part 2 of this chapter. Exercise 15C, question number 11. In triangle ABC, right angled at A. This triangle ABC, it's right angled at A. This angle is 90. AD is drawn such that angle DAB is equal to angle BCA. This line AD is drawn in such a way that DAB, angle DAB, that's this angle which is already marked, is equal to angle BCA, that's this angle. These two angles are same. If BD is 24, BD's length is 24 and DC's length is 3, D to C is 3. This much is 24, this is 3. Find AB. You have to find AB. Now if you look at this figure, you will see there are 3 triangles. First triangle is the complete figure, A, B, C. This one. The second one is A, B, D, small one. And the third one is A, D, C. This triangle. Now we are not going to prove all 3 triangles are similar. We are going to prove 2 triangles are similar. Okay. For that, you will consider one triangle, that is triangle ABD, that's this one, the smaller triangle. And the second one is not ADC, because if you consider ADC and this small triangle, one of these angles are equal, it's already marked. But there won't be a second angle which will be same in both. Okay. So in such figures where there are 3 triangles, it's always better to consider the complete triangle as one of the triangles to be proved to be similar. Okay. Complete triangle means triangle ABC is one triangle and the second one is the triangle which has the side AB. So that will be ABD, this triangle. Okay. 2 triangles which are going to prove similar are ABC, bigger triangle, and the smaller one ABD. Okay. Now let's see which are the angles which are same in both. Okay. In ABC, complete figure, if this line was not there, ABC, you can see one angle is marked, this one, with a single arc. Okay. And in the smaller one, this one, again, one angle is marked with a single arc. These 2 angles are same, which was already given. Okay. Now, talking about the second angle which should be same in both is this one. I am marking with a double arc. Okay. Look at the bigger triangle, triangle ABC. That's this line is not there. ABC, ABC has this double arc marking at B. Okay. If you talk about the second triangle, the smaller triangle, also has the same angle marking at the same point B, which means this B is common in both the triangle, the bigger one and also this smaller one. Okay. So if you look at both, the bigger triangle has a single arc marking, the smaller triangle also has a single arc marking. So one of the angles are equal in both. And about the second angle, in the bigger triangle ABC, angle B is marked with a double arc, and in the smaller triangle also angle B is marked with a double arc. Okay. So that becomes the common angle. So 2 angles are equal in these 2 triangles, therefore these 2 triangles are similar. So to write the steps for proving similarity, write down the 2 triangles, that is in triangle ABD, that's the smaller triangle, and triangle ABC, the bigger triangle. Okay. Smaller triangle, and this is the complete figure, bigger triangle. Okay. In this, the first step, angle DAB, this was given, angle DAB is equal to angle BCA. Angle DAB, single arc, is equal to angle BCA, that's also single arc. These 2 were equal. How did you know? Is it was given in the question. So reason given. The second one that we marked was this For the smaller one, it is ABD. Angle ABD is equal to, for the bigger triangle, this angle is angle ABC. Is equal to angle ABC. Both are same angles, therefore reason is common angle. So two corresponding angles are equal, therefore the two triangles are similar. Therefore triangle ABD is similar to triangle ABC. By this marking is angle, this marking is also angle. You write AA property, or you can write AAA property. Now that you know that these two triangles are similar, their corresponding sides are in proportion. Immediately after proving similarity, you will write this. Their corresponding sides are in proportion. Now, draw these two triangles separately. Okay. Even though one is small, one is big, it doesn't matter. Just draw two normal triangles. Okay. So what I have done is I have drawn two normal triangles. Okay. Okay. Now, name the first one and do the angle marking of the first one. Okay. So let's name the first one. A, B, D. That's A, B, D. A is marked with a single arc and B is marked with a double arc. I have not named the second one. That's supposed to be the biggest triangle. Okay. I have not named it, but do the angle marking in the same position. The top angle is a single arc and the angle on the left side is a double arc. Now look at the biggest triangle and name accordingly. Single arc is at C, so that's C. Double arc is at B, so this is B. Therefore, the other vertex that is left is A. And the sides which you know. BD is 24, DC is 3. BD, this one is known, this is 24, and DC you will find nowhere, okay. But you will find BC. BC, this one. Together is 24 plus 3, that's 27. Okay. So this is what is known. Now that both the triangles are drawn in the same fashion, okay, you can write their corresponding sides proportionally. So to write the proportionality is AB is corresponding to BC. So AB by BC is equal to AD by AC. Okay, AD by AC is equal to third side is BD by, this is AB, BD by AB. The question is find AB. So from here you find AB. So look for AB in this proportionality. You will find AB present here, AB is here. You will also find AB is here. So you will have to take both these ratios and leave away this, because AB is present in both. So AB by BC is equal to BD by AB. Cross multiply now. AB into AB is AB square is equal to BD into BC. AB square is equal to BD's value. BD is 24 into BC's value is 27. So AB squared is this one, which means AB is equal to square root of whatever is here. Okay. So I have written AB is equal to square root of 24's factors are 2 into 2 into 2 into 3. And 27's factors are 3 into 3 into 3. And if you see, you're going to find square root, therefore pair these numbers. Okay. The 3 and the 3 becomes a pair, this 3 becomes a pair, these 2's become a pair. This one is left separately. Now find square root. AB is equal to square root of this is 2 into 3 is 6, 6 into 3 is 18, and this remains under the root. 18 root 2, the units used were centimeter, so AB's length is 18 root 2 centimeter. Next, question number 6. In the figure, XY is parallel to BC. This is the figure given. ABC is a triangle. There is also one more triangle, AXY is the second triangle that is there. and it says XY, this one, is parallel to BC. These two sides are parallel. Given that AX is 3, this much is 3. XB is 1.5, this much is 1.5. And BC is 6, this whole length is 6. Find number 1, AY by YC. AY by YC. This divided by this is what you will find first. Second question is you have to find XY. Okay. Before we find any of these things, first thing is you have to prove that there are two triangles and these two triangles are similar. Okay. The two triangles are AXY, the smaller one, and the other one is ABC, the bigger one. Okay. There are only two triangles here. Okay. AXY is one and ABC is the other one. Now you have to mark angles which are equal in both these triangles. Okay. For that, look at this. This angle is equal to this angle. Why? These two are parallel, therefore these two angles become corresponding angles. Okay. So, the smaller triangle has a single arc, the bigger triangle also has a single arc. Okay. The first corresponding angle is same. The second one, I'm going to mark this with a double arc. Look at the small triangle. The small triangle has a double arc. The bigger triangle also has a double arc at the same point A. So A is a common angle in both the smaller triangle and also the bigger triangle. You can mark this, or you can also mark this angle and this angle are equal. They are also corresponding angles. Anyway, so let's write proof of similarity for this. So the two triangles that you are going to consider are in triangle AXY, that's the first one, and triangle ABC is the second one. The first angle which was same are these two. Angle AXY, this one, angle AXY is equal to, single arc is ABC, angle ABC. Why these two are equal? Corresponding angles. Second one was this, for the smaller one, this is XAY, angle XAY is equal to, this for the bigger one is BAC, angle BAC. Why it is equal is both of them are common angles. Okay. Now that you know two corresponding angles are equal, therefore the two triangles are similar. Therefore triangle AXY is similar to triangle ABC by property marking here angle, angle property or angle, angle, angle property. Okay. Now that you know the two triangles are similar, their corresponding sides are in proportion. Now, to draw both the triangles, okay, just draw two triangles, two normal triangles like this. The first triangle is AXY, you can name that first. Okay. So, this is A, X, and that's Y. And let's look at the angle markings in this. A is marked with a double arc, X is marked with a single arc. A with a double arc and X with a single arc. I have not named the second one. I will do the angle markings first. Double arc is here, so a double arc here. Single arc is here, so a single arc here. Now I have to name the second one, bigger triangle. Okay. So let's name the bigger triangle. Double arc is A, the single arc is B. So this is A, that's B, therefore this should be C. Now both are drawn in the same way. Their corresponding sides are in proportion. Write the proportionality now. AX by AB is equal to AY by AC is equal to XY by BC. Now, the first question was find first subdivision AY by YC. AY by YC. But if you look at the proportionality, there is no AY by YC at all. Okay. Now, in such figures where you have one triangle inside the other one and one of their sides are parallel, normal proportionality, you got three corresponding sides proportionality. There is also one more ratio that you proportionality that you can get, that is AX by XB is equal to AY by YC. This is called basic proportionality theorem. Okay. Only for such figures where there is a smaller triangle inside a bigger one and one of their sides are parallel, there is a second proportionality that you can write. The second proportionality is AX by XB is equal to AY by YC. Okay. So what I have done is I have written the second proportionality, that is AX by XB is equal to AY by YC. That's called basic proportionality theorem, applicable for such figures. Okay. This is what is asked. First question is AY by YC. So first subdivision, this is what you can find. So you have to know what is AX and XB. Okay. If you look at the figure, AX and XB you have to know. AX is 3, XB is 1.5. AX is 3, XB is 1.5 is equal to AY by YC. You have to simplify this. If you remove this, this becomes 30 by 15. 30 and 15 you can simplify, it becomes 2 by 1. That's AY by YC. That's the first question. AY by YC is 2 by 1. Okay. Second question was, you have to find XY. This is XY. Okay. So to find XY, two proportionalities I have written. Okay. Using this basic proportionality theorem, you won't find XY. There is no XY at all. So which means you have to use one of these. Okay. So XY is what we are going to find. XY is here. So you have to use this. And you have to use either this or this. If you look at the figure, you know AX and AB. AX and AB. Check. AX is 3, AB, the whole thing is 3 plus 1.5, that's 4.5. This much is 3, the whole thing is 4.5. Okay. So, we are going to use this and this. So, for the second subdivision, AX by AB is equal to XY by BC. AX's value according to the figure is 3 and AB was the whole length, which is 4.5, is equal to XY is what you are going to find by BC's value, is also known as 6. Okay. You can remove the decimal, this becomes 30, so that's 30 divided by 45 and the 6 comes this side into 6. Okay. Is equal to XY. You can simplify this, both can be divided, both can be divided by 15, this will go twice, this will go 3 times, 3 and this will go 2 times, 2 into 2 is 4 centimeter is XY. And today's homework is exercise 15C, from 15C, question numbers 4, 40 subdivision 1 and subdivision 2, and from exercise 15A, question numbers 1, 10, 19 and 17.